This is section 8.5, problem number 4. Here's what we have. I just summarized the data over here, but it says we have two populations. They're independent. So a random sample of 49 measurements from one population had a sample mean of 12, standard deviation of 5. 64 were sampled in the second population, gave a mean of 15 and a standard deviation of 6. And what we want to do is test the claim that the population means are different. All right, so if somebody thinks that maybe these are different, and there seems to be some indication. I mean, one mean is 12, one's 15. So there's at least a numerical difference. Let's test the claim for sure that these two are different. So we're just asked to test that they're different. So I could say this. I could say mu1 not equal to mu2, or I could say that mu1 minus mu2 not equal to 0, right? This one says that directly that the first mean is not equal to the second one. This one says that the difference is not 0, right? It's a non-zero difference, which means that they are different. H naught states that mu, get it to right here, that mu1 minus, or say is equal to mu2, or if you like, mu1 minus mu2 is 0. So part A, what distribution does the sample test statistic follow? Well, let's see. We are given large samples, but we don't know the actual population standard deviations. So let's use a t-distribution. If we knew the actual sigmas, we could use the z, but we don't. So let's go with, all right, that's a normal. Let's not do that. The student's t, we assume that both populations are approximately normal with unknown standard deviations. That's what we have. We have the statistics, but not the parameters. All right, so we're going to go with this one here. I'm going to read the others just to be sure. It's not the standard normal. Students t, we assume both distributions are approximately normal with known standard deviations. No, we don't know the known standard deviations of the sigma. We're going to go with this one. Part B, state the hypotheses. All right, this says that the means are equal. All right, the alternate is that it's greater than. Now, they just have us testing that they're different. All right, they're different. Not one is greater than the other. The only one that's different is this one right here. All right, so let's go with that. Now, we need to compute, part C, x1 bar minus x2 bar. Okay, well, we can actually do that because what do we get here? Here's our values right up here. So how about if we did this? x1 and x2 would be 12 minus 15. The way I wrote it here is negative 3. And now here, compute the corresponding sample distribution value. All right, let's put this in our calculator and have the calculator do all the hypothesis testing work for us. We will go to Stat, over to Test, and now what are we doing? We're using two samples, right, and we're using a t-distribution. So we're going to go to Stat, over to Tests, and do you see it there? Number 1 is a z test, 2 is a t-test, 3 is a two-sample z-test, number 4 is what we're looking for, two-sample t-test. So go down to 4, select 4, which is a two-sample t-test. Now when you select that, here's all that we're asked for here. Now what's our input? Well, we're not putting in data, right? We're just putting in statistics. We already know the values. These are all the statistics. These are numbers that come from sampling. They're not the actual data values. So we're not going to input data. Put in statistics. So put your cursor on statistics and press enter. Now for x1, we're going to put, what's our first x1 bar? Maybe it's 12, right? It doesn't matter which one you use. We'll use 12. That sample standard deviation is 5, and that population, or the sample size is 49. Now, for population 2, the mean is 15, standard deviation is 6, that sample size is 64. And then what are we testing over here? We are testing what? What's our alternate hypothesis? we're testing that they're different, right? They're different. So we're testing this one here, that they're not equal. So run your cursor over here, choose not equal, press enter. Now it says pooled, all right? The choices are no, yes. We are going to assume yes, that there's just one big population. If there's no difference, just one big population. So put your cursor on yes, and then go down to calculate and press enter. Now when I pressed enter, this is the important information that came up. Calculator reminds me again that that's my alternate hypothesis. I'm testing that the two means are not equal. Here's my t star value. Now that's what they're asking us down here. All right, so negative 2.83. Let's put that right in here. Negative 2.83. Now they're asking us to estimate the p-value. All right, well, what is our p-value here? Oh, that's very small, right? 0.005, that's about, a 0.5%. So which one is that going to match down here? All right, well, this is 25%, 10%. That's 5%. This is 1%. This is less than 1%. And we're at 0.5%. So we are going to go with this value down here at less than 1%. Now it's a p-value that we use to decide if we're going to reject or fail to reject H0. So what have we got here? I always do my little table here. So I got p and alpha. Now p is 0.0056 and alpha, now they're giving us an alpha, right? They always have to in these textbook problems. They want us to use 0.01. So 0.01. Now this is 0.5%. This is 1%. So 0.5% is less than 1%. Now if you remember, if it's less than 1, then we're really small. We reject H0. That's a small probability, which means it's unlikely. And if it's unlikely, I'm going to reject H0. So let's see which one of those is our conclude the test. At alpha equals 0.1, we reject and conclude that the data are not significant. Well, if you reject, the data are significant. So we fail to reject. What's this one here? At alpha equals 0.1, we reject the null hypothesis and conclude that we have significance. That's the one that we want right there. Now we're rejecting H0. So what is H0? H0 was, okay, let's go back here. I'm going to go back a page. Guess not. Okay, what was H0? H0, oh, we have it right up here. H0 says that the means are equal. We're rejecting that in favor that they're not equal because that's what we were testing. So let's say, reject the null hypothesis. There is sufficient evidence that there is a difference between the means. That looks good. Let's see what the other ones say, though, just to be safe. Fail to reject. No, we're not failing to reject. We're not failing to reject. This says reject the null hypothesis. There's insufficient evidence. Well, that's not true. We have significant evidence. So we're going with this one right here.